So my name is Konrad Kamiński. I work for Allegro, so we're the largest Polish e-commerce company. And today I'd like us to see how we can write asynchronous applications with Spring and with Kotlin Coroutines. So have a look at this code. It's quite a simple code. There is a web endpoint, a web method, which takes one parameter. And in that web method, we do two things in sequence. So first, we actually check if a user is a valid user, if it has an access rights to something. And later on, we are getting a list of products for that user. So the code is quite simple, straightforward. You can just have a look at it, and you know what happens. But there is one problem with this kind of code, or essentially these kinds of applications. So let's imagine that the isValid user or the getProducts functions, they go over a network to fetch some data. So for example, the isValid user accesses some external service, a REST endpoint. And the getProducts function, it fetches some data from a database server. So it means that at some point in time, they will block because they will send a request over a network, and they will wait for the response. And since they are blocking calls, the threads that execute those functions will be blocked. They will just be there and do nothing. And each thread actually consumes some resources. So things like memory or CPU, they are all consumed by threads. So if we have like a couple of threads, that's not really a problem. But today we write applications which serve millions of users. So essentially, we could end up in a situation where we have millions of threads essentially doing nothing, just blocked, waiting for something, for some data, and they consume resources. So that's a waste of those resources. And actually, you can't really have millions of threads on a single machine. That's not doable on contemporary machines. So what can we do? So the usual answer to that problem is some form of asynchronous programming. So first, the first one that's more straightforward is callbacks. With callbacks, we pass as a parameter to our function a callback, which is called whenever the result is available. And callbacks have their own set of problems. So you probably are familiar with something which is called callback hell, where you have those nested callbacks, one in another, and your code looks like a tilted Christmas tree. You have like all those curly braces at the end. And if you want to use things like exception handling or loops, then it's really hard to write that kind of code, and it's really hard to read that kind of code. So that's not really a solution for longer term. The other solution can be to use some form of promise type object. So if you think about things like completable future in Java or reactive streams libraries, they all actually use some form of promise type object. So with promise type objects, the solution is a bit better than with callbacks because we no longer have these nested callbacks, but still we have to we have to use some functions of those promise type objects where we provide functions which are executed when there is a value available or when there's an exception thrown. And each type of promise type object API, it has different set of those functions. So when you learn one of them and you want to use a different one, you have to relearn these APIs again. And also your code doesn't actually look as good as the one that you see here, because you have to restructure your code so that it's more written like in a functional way. But with Kotlin, in version 1.1, came a feature which is called coroutines. So coroutines have been actually invented almost 50 years ago, but they made its way into Kotlin just about a year and a half ago. And with Kotlin Coroutines, you can write asynchronous applications in this imperative style, and you don't have to learn anything new and a new API. So it will be great if you could use Kotlin Coroutines with Spring. Now, the problem is that currently Spring will not work out of the box with Spring. And to learn why is it like that and what we can do to actually make it work, we have to first learn how coroutines work in Kotlin so that we know where the problem is. So here you can see a simple function, a simple suspending function, because coroutines in Kotlin, they are made from suspending functions. A suspending function can suspend its execution in some places and then resume its execution, possibly on a different thread. So when I say that a function is suspended, it doesn't really mean that the thread that executes this function is blocked. It just means that the code is actually, the execution of this function is suspended, and it will, once it will resume, it will start re-executing on a different or the same thread. So here we have a simple suspending function, takes one parameter, it returns some value, and inside it uses delay function. So a delay function is a sort of equivalent of sleep that you have for blocking operations. So sleep will actually block the thread. Delay is a suspending function, so it will not block the thread that executes this function. It will just wait for 5 seconds. After 5 seconds, it will resume the execution. So how does it work? If you look at how the Kotlin compiler behaves if it sees suspending function, you can see that it actually converts your code so that the final code is actually callback based. So we're not providing callbacks explicitly, but the compiler does it for you. So in our case, our function will have this additional parameter, this callback parameter, which is of type continuation. And the return type of our function now is any. So any in Kotlin is something like object in Java. And the reason why it's like this is that a suspending function can actually either suspend or not suspend. So if it doesn't suspend its execution, it means that it wants to return the value directly. And then it just returns this value. So nothing really is different from the regular function. But when it wants to suspend the execution, it returns this special marker value, which is called coroutine suspended. And then the caller of our function knows that this function suspended its execution, and the true value will be delivered with the usage of this callback that we pass to the function. And the callback, it has two functions. One is used for returning a value. The other one is used for returning an exception. So if a suspending function wants to throw an exception, it will use the resume with exception function. Now, this is something which is prior to Kotlin 1.3, which will be released probably next week. In Kotlin 1.3, you will have only one function, which is called resume, and it will take a result type. And the result actually will contain either the value or the exception. So this is a small difference which will be introduced in Kotlin 1.3. But other than that, the rest is the same. So the problem that we can have with Spring is that Spring, in a lot of places, in a lot of features, it assumes something about the signatures of the functions and even tries to do something based on the signatures of those functions. So let's have a look at this example, at this code that you would like to have. So we'd like to have a web endpoint, a web function, which is a suspending function. Now, when Spring executes this web function, it looks at the parameters of this function and tries to provide instances of these parameters. So for example, here we have a path of variable parameter. So Spring will try to provide a value for that based on your request path. But you know, this is a suspending function, and Spring doesn't really know anything about suspending functions. But it will actually see this continuation parameter, and it will try to provide a value for that, but it doesn't really know how to do it. And there's also this different semantics of execution. So our function now can not only return the value directly, but this special marker value, and it changes the semantics of the execution. So Spring doesn't know anything about that. And so what can we do? So actually in those different areas of Spring, different features, we can provide our own sort of plugins to make Spring work with suspending functions. Now, I'm not going to go into details of how we can do it, because we don't have that much time. But anyway, if you're interested, you can have a look at a library which I want to show you, how we can use it. And it's called spring-kotlin-coroutine. So it's not an official Spring framework project. Some of the things have been ported into the Spring Foo project, but not all of it. And with this library, you can use features of Kotlin coroutines. So essentially, you can use suspending functions in many different areas. So what I want to show you is I want to convert the application which uses blocking I/O, which uses external services and databases, to the one which uses coroutines, just by changing a little code. And at the end of this exercise, we should have an application which uses non-blocking I/O and which is asynchronous and which uses imperative style. So let's try to do some coding. Okay, so here is our original application. It has a regular function, a regular web function. So we're going to convert it to a suspending function. But that doesn't really change much. We still doesn't, our function doesn't suspend here at all. So what we have to do is we have to change the other functions to be suspending as well. So let's go to the isValid function. So isValid function uses REST template for accessing external endpoint. So we're going to make it suspending as well. Now, if we go back, we can see this marker here. So this marker means that here, our function, our getProducts function can suspend its execution because it calls a different suspending function. So in theory, it could suspend its execution here. Now let's get back to our isValid function. So it will not suspend its execution because it's this REST template which is essentially blocking. It is a blocking API. So what can we do? So usually if you have a blocking I/O or a blocking API, you can try to use this architecture of applications where you have different thread pools running those functions, and by having different thread pools for different areas, your request will not actually block one single thread for the whole execution. It will just go from one thread pool to the other during the execution of the whole flow. And that way, you will not end up with millions of threads being blocked, but only a couple of them, because you can actually scale the number of threads in those thread pools. Now, this is quite simple to do with coroutines. We can use coroutine context for that. And coroutine context is actually something which, well, actually plays several roles, and one of them is that it can be a coroutine dispatcher. So a coroutine dispatcher is responsible for scheduling where our coroutine will be executed, on what thread. And you can create your own dispatchers, or you can use the default ones. So first, let's try to use the default ones. The default one is very similar to fork join pool. So if you've ever done any asynchronous programming with Java, you may be familiar with fork join pool. So this is all we have to do to actually make this function a suspending function, which will suspend until this getFromObject is executed in a different thread pool. And to actually observe that, we can add some logging here. So let's try to add logging here before getFromObject and after getFromObject. Okay. So, and also let's add some logging here so that we can observe threads here as well. Okay. One more thing which you have to do also is to enable coroutine support with the enable coroutine annotation. And that's actually everything we have to do. So let's try to execute it. And there is this endpoint that we have to access. So there is a user ID we have to provide. There is a database filled in with some values at the start of the application, and it has some data for the user Konrad, so I'll use that. So let's try to call for the endpoint. Users Konrad products. Right, so we have some JSON here, and we can observe in the log output that we use 2 different threads. So when we start executing this getProducts web endpoint, web function, it will use the thread from the web container. But then it will try to get the information about the validation of, about the fact that the user is valid in a different thread, from a different thread pool, this fork join pool, which I talked about. So this is all nice, but it would be really tedious to actually use that with context for every function that we have that we want to use some context. And this is why the spring-kotlin-coroutine library supports an annotation, which is called coroutine. And there you provide actually a name of a bean, which is a context, or which can be converted to a context. So it can be a scheduler from RxJava, an executor. There's like a couple of options. So let's try to create one, external service context. So we will not need this anymore. And here we'll add the return. And in fact, you can actually put that annotation on a class. And by doing that, we will ensure that every suspending function on that class, in that component, will actually use this, this context. We can even do more. We can even create an annotation class. And service, yep, and add it here, so that if we have multiple such components which access external service and we want to use a shared coroutine context, we can just put this annotation on our class. Now, one more thing which we have to do is we have to create an instance of this, a bean of that name. We can use a very convenient function. So there's like a couple of functions in the Kotlin Coroutines library which allow you to create context. So we could use, for example, new fixed thread pool context, which will create a coroutine context which is backed by a thread pool with a fixed number of threads. And we can provide the number of threads and the prefix for the names of the threads. So this should allow us to now to see that the REST template API will be used in those threads. So let's try to curve for it once more. And we can see that it uses threads from this coroutine context. Now we can do actually the same thing for the database access. So here I use Mongo database. I use Spring Data. So I can actually make the function of this product service, which returns this list of products suspending, and add a coroutine annotation as well. And do almost the same thing as before. So we're going to return this. And let's add some logging here before this and after this. Okay. One more thing, we have to create a Mongo context. I forgot about it. Okay. So we're going to have a different context for Mongo. So we'll call it, the threads we'll call Mongo. So now it should finally work. So now we have an application. We should have an application which uses these 3 different thread pools, one in the web container, the other one is for the external service, the other one is for the Mongo database. And let's see if it actually works. Right, so we start in a thread from the web container. Then we call the REST endpoint in the external context, in the context with this external 1, 2, 3, etc. threads. And we end with threads with Mongo. Now this is all very nice, and it's quite easy to convert your existing applications to to work in such an architecture. But we still use blocking API. So we still have that problem that we have threads doing nothing, just waiting for the response from the server. It's not that many of them. We can actually somehow scale our application, but that's really, I mean, we could do better. So in Spring 5, we have now this reactive types, generally reactive APIs for many different things. And the nice thing about the implementations of those APIs is that they use non-blocking I/O. So for example, for the web layer, we have webflux. For I mean, we can't use REST, we shouldn't really use REST template anymore. It's deprecated in Spring 5. You should use web client, which has a reactive API, and it uses non-blocking I/O as well. For Mongo, we have reactive Mongo repositories, which we can use, and it uses a reactive driver from Mongo, which is non-blocking as well. So it would be really great if we could somehow leverage that, these implementations. And in fact, this is actually possible with the spring-kotlin-coroutine library. So let's try to convert our application to the one which is non-blocking I/O and see how hard it is and how it really how it works. So first, let's try to start with the web layer. So all we have to do actually is to change some dependencies. So we use WebMVC so far. We've used WebMVC so far, and now we're going to use webflux and a coroutine support for webflux. So let's try to just change the dependencies, and let's try to re-execute our application. Okay, it's starting. Okay. Let's scroll for the endpoint. So nothing really changed here. But if you look at the output of our application now, you see one thing, actually a couple of things. So we now use Netty instead of Tomcat. So before we used Tomcat, now we use Netty, because Netty is the default web server which is used by Webflux. And so that's one sign that we're actually using Webflux. The other one is now we start handling our request in the Reactor thread. So what actually happens is coroutines under the hood, they actually use Webflux reactive API. They are just wrapped around, but you actually can't see it. So you can use suspending functions as you did before. So I haven't changed a line of code here, and we still have a suspending function here. It's just that now it uses webflux underneath and not WebMVC. So now we have non-blocking I/O with coroutines in the web layer. So let's try to make it work for the other features. So let's go to isValid. So as I told you, that we shouldn't really use a REST template in Spring 5. In Spring 5, instead, we should use web client. Web client is a very simple API. So we can actually rewrite the code that we have here. Let's make get, retrieve, and body to mono. And now, okay, body to mono, and now it's string class. And now let's try to assign it to a variable, so that we can see that the result is actually of type mono. That's the reactive type in Spring. And but we want to use coroutines and not care about things like reactive types. So what can we do is actually we can do two things. We can either use some extension functions which are defined on the reactive types, like for example await, first, or null. This is a suspending function, as you can see here. And it will wait until there is some value in that mono, and it will return that value, or will throw an exception. So we can do that. We can then convert it to Boolean, and if it's a null value, we'll just return false. So now our result is a Boolean, and this is what we wanted. But the price is that we have to use both reactive API and some extension functions. So this is not really nice. And this is why in the spring-kotlin-coroutine library, we can use coroutine web client. it has a very similar API to web client. So if you know web client, you can easily use coroutine web client. And there is no body to mono because there is no mono in coroutines. There is just body. And we don't have to use the await function anymore. And we can leave the rest here. So we can now see that we have two suspending functions here. One which retrieves the result. The other one is for getting the body of the response. But there is no mono here. I mean, there is no reactive API used, at least superficially, at least if you look at the code. So we can change that to use the result. And what we can do is we can get rid of our custom context. We don't need it anymore. We can get rid of REST template. And now we should have an application where the web layer uses the non-blocking I/O, and this web client also uses non-blocking API. So let's try if it works. Okay, so our isValid function also uses reactor. So we have non-blocking I/O in the web client as well. And one thing which is left is the database. So we use a Mongo repository here. And with reactive data Mongo, there's a reactive Mongo repository. And for coroutines, there is coroutine Mongo repository. We just have to add some dependencies here. And yep, so now it's a coroutine Mongo repository, and we can make our function a suspending function. So we can get rid of this coroutine annotation here. And one thing which is left is this. So as I said before, when we start the application, it's actually filled in with some values at the start of the application, and it's done when you actually, when there's an event, application-ready event sent. And since we now have suspending functions, we can't really invoke it in a regular function. So there's a rule, you can't invoke suspending functions in regular functions because of this different semantics. So we have to actually make this function a suspending function, and it actually shows you one more feature of the spring-kotlin-coroutine library, where you can actually have a listener for the events, and there's also a publisher for the events, which is suspending functions. So we can have this asynchronicity end-to-end. So let's try to execute our application now and see if we have the non-blocking I/O part in the Mongo database as well. Okay, something usually happens during live coding. Okay, let's try to find out what it is. Oh, one thing I forgot is, of course, it's enable coroutine Mongo repositories that we have to add to actually have support for coroutine Mongo repositories. So let's now try to call for the endpoint once more. It works. And we can see that the function which gets some data from the database are here. So it starts in a thread from Project Reactor, but after that, it finishes in a thread, which is, it's called NIO event loop group. So it's a thread from a thread pool used by Netty, because the Mongo driver, the reactive, the asynchronous driver uses Netty for I/O. This is why you actually see these threads here. So now we have an application which is non-blocking, which uses asynchronous programming, and it's written in imperative style. And what I wanted to show you also is that you can actually change your existing application to the one which uses suspending function, which is coroutines, easily. And you can do it either only on a web layer, or you can use it on a database layer. You can use Spring MVC and then turn to webflux, whatever you want. There's like a lot of options here. Just a few things more. So, I mean, there are more features in the library which I haven't shown you because there's no time really. But there is support for things like scheduled jobs. There is support for caching, a couple of other things. So if you want to know more, go have a look at this GitHub repository. You'll find source code, some documentation there. So go have a look. Also, there's the Spring-Foo library, which is done by Sebastian Deleuze, and he's actually ported some of the things from this library to Spring-Foo so that you can use coroutines there as well. So that's all from me for today. Thank you. And if you have any questions, you can just grab me after this talk. I'll be happy to answer them. Thank you.